I got a new one. Oh, I didn't play the sound because I have my thing off. There. No Leah? Well, it's probably not. Right. Something's wrong. You go split up, search the school. Leo would play guitar. Well, hold out hope. Oh, hi, Leo. And it's Haley, Jordan, McChicken, and Kaylee. Oh, further out. What's up, Jordan? All right, I want to continue our discussion of subtraction today. But before we do, I'd like to make a few announcements. So, for those of you that have not, and this applies to people both online and here in person, have not met with me for portfolio conferences. I would not like to make a habit of this, but today, and today only, if you act right now, a special offer of 105 to 325, you can meet with me online. How's it going to work? Do you sign up for a time? No, I'm not making another sign-up time. That would require work from me, which would be infinitely more work than you put in. So what I'm going to do instead is I'm going to be available during those times. I'm going to give you guys a link through an email pretty soon. And if you want to show up for a portfolio conference, show up to the Google Meet. First come, first serve. And I'll be doing that from 105 to 325. If you have done it already, did you feel like portfolio conferences were good? Like not a waste of your time, useful? Okay. Awesome. I want to keep doing them. The plan is to increase the time that I have with you guys, so it's not just me talking at you for 5 minutes. I'd like to have about 10 minutes. That way we can talk more back and forth. And the way I'm going to do that, since there, I have 69 students, there is not enough time in the day to give you all 10 minutes. The way I'm going to do that is I'm going to split up every other week. We'll have portfolio reviews, so A day, B day type of thing. And what's up, McChicken? And if you want to show up on the week that isn't your week, that's fine. It won't be for a grade, but you can get feedback, right, if it's useful. But otherwise, it'll just be the kids that are required to every other week. That'll be the plan. Bruh. All right, so missing Kaylee and Haley, I think, are the only two that we're missing right now. So we're going to continue our discussion of subtraction. Again, special offer today, 105 to 325. I'll be here. Show up to the Google Meets link that I send you. If you need to do portfolio stuff, make sure you're bringing your A game. Midterms, or mid-quarter grades. I don't know any other school that does this. Mid-quarter grades are due today, essentially. So your grades will be in by Tuesday, which is really the final day. But no new grades will go in. So if you haven't met with me, you're going to have a 0 for the first half a quarter, which would be real bad. So get that done. Again, 105 to 325 is the time to meet with your boy. Okay? That is the plan. And again, today we're talking about subtraction. We're going further into it. If you were paying attention yesterday, awesome. Haley, we got to meet for your portfolio. Make sure you do that. I'm available from 105 to 325. I'll send you guys out a Google link later. So, talking about subtraction yesterday, we talked about subtraction being distance, right? This is very helpful because you can do stuff like this. So if I know I've got 52 minus 27, I know that's the same question as 50 minus 25. And the reason for that is pretty simple. Two numbers separated by a certain amount, right? We want to know the distance between them. Here they are. Now, if I shift them both over the same amount, the distance stays the same, yeah? So I can shift them as much as I want as long as it's both the same. Because it won't change the distance. It doesn't change the problem. It's just a different way of looking at it. What are you going to say? You have something to say? You do it the other way around. You could think of it as 50 minus 25 and then add on 4 or whatever. Or Or, well, actually, hold on. What are you saying? Walk me through it. Are you working backwards? Is that what you're doing? Oh, so if you had this problem, you could change it back? That's true. That's true. Right. I think what you were trying to do at first is trying to think of this like as 50 minus 27, maybe? And then add 2 on later. Yeah, you could do that. But if you're going to do that, might as well shift. But yeah, that's a good point. Right, you can think of this as 50 plus 2, take away 20, take away 7. Again, we're taking away both 20 and 7, right? That's what take away 27 means, right? So you wouldn't do minus 20 plus 7, right? So here we get 30. 2 minus 7 is negative 5. Now speaking of 2 minus 7, 2 minus 7, the distance between 2 and 7 is 5, undoubtedly. But remember, the second number is where we start, and direction matters. 7 going to 2 is minus 5, right? Whereas 2 going to 7 is positive 5. Kind of goofy. Where we start is always the second number. But what's nice about this is 2 minus 7 is kind of a hard problem, right? Especially for like 6th graders. But you can flip it in your head and do 7 minus 2. Super easy, 5. And just remember that you changed the direction, right? You're not going from 7 to 2 anymore. You're going from 7 to 2. So to get back to what you wanted, you have to change the sign, right? Signs are only direction. That's all it is. That's all it is, a direction. So 42 minus 56 is a tough problem, right? But 56 minus 42 isn't very hard at all. But we need it negative if we're going to answer this question. Because it changed direction on us, right? Well, this one's positive. Sorry, my writing isn't very clear. This is positive, right? But in order to answer the original question, we have to remember we changed the direction. And so it's just the same thing but negative. That's all. Again, shifting is very nice. I like that strategy a lot. Let's mess around with that for a little bit. All right, McDonald's, give me a number. What do you want? 75. Oh, okay. Not very exciting, right? We could shift them both. Obviously, the answer is negative. Distance is 10, right? I usually think about what the answer is first, negative or positive, and then just forget about it, right? Write it down and forget about it. That's right. Camden, number. Ooh, okay. Mac, number. How would you solve a problem like Maria? How would you? By the way, I want you to write in your portfolio, and I know this is kind of breaking the rules here, but I want you to write about either one of addition, subtraction, or multiplication, explaining the different methods, not just, hey, they work, right, and here's how you do it, but why they work, right? Why does borrowing here for subtraction work, right? We're borrowing a 10, we're thinking it was 10 plus 1 instead of 21, right? Makes it easier to subtract, et cetera, right? We'll talk about that today. Really go into it, okay? One of those things. What about this? How would you do this? What would be your preferred method? Yo. Okay. Are you taking... So say it again. Say it again. I think I know what you're talking about. It's okay. It's okay. You're thinking outside the box. It's all right. Sometimes it happens. What's the traditional method? 3, and then 6 minus 6. 1 minus 4. Uh-oh. Is it? Does it work? Does that actually work? 100 minus 400 is negative 300. That's right. 67 minus 64 is 3, but it's a positive 3, right? Yeah. So it's more like 97? That's weird, right? Let's talk about that again. Normally, like, borrow, but, like, we couldn't, right? There's nothing more to borrow. You see how this breaks down when we have a negative answer? Yeah. And this is why you guys get confused when we introduce negative numbers. It's not because you can't understand that, oh, -6 is just below 0. You can figure that out. The problem is that we taught you this is how subtraction works. You borrow, whatever, right? You know? And then all of a sudden, no, it's not how that works. And you're like, wait, what? I just spent 3 years memorizing how to do this method. It doesn't even work. Hey, when that happens. So, yeah. And then remember that the sign needs to be changed, right? It's going to be negative. So we do 4 minus 7. How do you do that? Cross it out and borrow, something like that, right? That 60 becomes a 50. So we're thinking of that 64 instead of as 64. We're thinking it as 50 plus 14. You dig? And then 14 minus 7 is 7. 50 minus 60, uh-oh. Now we're thinking of 150 minus 60, 90. Sorry, 300 minus 100, 200. I was right. Actually, no, I wasn't. Oh my god. I missed this guy. See? Tricky. You can do that. You want to see something wild? Oh yeah, and by the way, it's negative. You want to see something wild? The Josh Morris method. He did not invent it, but he thought of it all on his own today. I was pretty impressed. I was going to show it to him. Let's go left to right. What does that 1 stand for? What's 100 minus 400? It's going to be negative, right? So 300 is the difference. What's 60 minus 60? Awesome. Don't write anything. If you want to, go ahead. What's 7 minus 4? Hi, Kaylee. No borrowing. None at all. Why don't they teach you this? How long have you been doing subtraction? At least. Right? And they couldn't take one day to be like, hey, by the way. Maybe even earlier. Taking away apples? Yeah, sure. You don't have to borrow. You can just go left to right. 100 minus, and again, you need to know negative numbers for this method, right? Because we have a negative answer. But maybe that's why they don't teach it. But also because I don't think teachers know you can. I think their teacher didn't know, and so they never taught him, and their teacher didn't know, so they never taught him. And maybe like 5 teachers ago, that person did know. But this requires you to know about negative numbers. It makes you have to really think about 1 and 4, what they mean, 100 and 400, right? And thinking takes time, and time and thinking aren't things that we always want you to have, right? We want you to be able to go into a factory, or at least we did, right, before there were calculators and stuff, and make sure you got the answer right. And this is a good way to screw it up. You could think of that as 300 positive, or, you know, think of that as a minus, you know, all kinds of stuff. So they give you a method that you memorize, and you practice over and over and over again. And as long as you do the method right, you got it right. And not only is this good for making sure the money keeps flowing, because you're doing your factory job, but it also makes sure that you're a good factory worker, but you're not a good factory owner. You can't become one. You can't think outside the box. You can't think for yourself. It perpetuates that status quo. But it just wasn't profitable to teach you guys that way. Yeah, 100 minus 400, negative 300, nothing, 3, negative 297. Negative 300, but 3 to the right. Again, the difference between these 303, 297 is the difference, right? That's pretty easy to see. Question is it negative or positive? Well, negative, because that's bigger, right? Bigger. Let's do another one. Yeah, give me one. Give me another one, Camden. 700 flat, huh? Okay, answer's gonna be negative, so we don't forget. 500 minus 700. 70 minus 0. Positive, right? 60 minus, or 6 minus 0. We have 76 minus 200. Think about it, think about it, think about it. 270. Hold on. 270 separated by 130, right? And we're asking about separation here, basically, because there's a minus here. So 130, but it's going to be negative, yeah? 130 and 6. Difference between them, 124, right? That's one way to do it. Can't even borrow, right, when the answer's going to be negative. What about 500 plus 70 plus 6 minus 700? You notice something? Same thing we had before? Breaking it down, right? Break it down. That same one. 576, yeah? What if we shift, right? Remember, as long as we move both by the same amount, the distance will be preserved. Now, 700 is really nice, but I'd rather make this guy nice if I can. What do you want to do? Make that 580? -76? -200? I don't know. Something like that? Yeah. Thank you, Zed. Zed, check this out. Check this out if you're still in chat. 5 minus 2 is the distance between 5 and 2, yeah? Right? So let's check this out. Subtraction is distance. We did this yesterday. 21 minus 7. He's over in some other class right now. What class are you supposed to be in? 21 minus 7 is the same thing as 20 minus 6 because the distance between two numbers is the same if you shift both the numbers the same amount, right? See how 21 is now 20, 7 is now 6? We shrunk them both by 1. So two numbers separated, right? That's their distance. We shift them both left by 1. See how the distance didn't change? So this answer will be the same as this answer. Has to be. So this one's way easier to do. Hey, what did you say? Oh, sure, yeah, shifting it over. Yeah. True, right. Extra or double, right? Extra 2. Y'all play football? We said no. You don't? You're a baseball guy, right? That's what I thought. Gotcha. What'd you play when you played football? Running back? I could have guessed that. The chicken. Oh, he doesn't like getting hit? That's what offense is all about, buddy. Oh, gotcha. Okay, that's cool. Camden, how about you? Same? Running back, cornerback? What do you guys play? Line. Knew it. Knew it. Knew it. In the haircut. In the haircut. Yeah? You mean enough to do that? I don't know about that. You're gonna have to get mean. You're gonna have to get angry. Nobody talking about my mama! So I'll send you a link later on through email, and then you can click that link, first come, first serve. You can wait around until the other people bail. It's up to you. All right. So subtraction, distance, we talked about that. We talked about this weird method of like just subtracting. 800 minus 0 is 800. 40 minus 90 is negative 50. 6 minus 8 is negative 2. Right? 800 minus 50, 750, subtract 2 more, 748. Done. Josh Morth method. I'm a big fan. Big fan. Also, we can shift that, right? Oh, yeah. Big fan. Big fan of that one. Okay, cool. Did you really? Last year in my class? I don't know about that, buddy. We did talk about subtraction of distance. All none of you guys remember that. That's key, man. Key to that understanding of why that works when you shift stuff over, right? If you're not thinking about distance. Because it doesn't work with addition, does it? Like 5 plus 7 isn't going to be the same thing as like, I don't know, 10 plus 17, right? Or not 17, 12. Right, shifting both 5, that's not going to work. it's only because we're talking about distance that that property works. It has nothing to do with adding to both sides or any PEMDAS nonsense. That's the key. I want to talk a little bit about division today. A little bit. Say again? Yeah, it doesn't work for addition, doesn't work for multiplication. Does it work for division? Maybe there's something like that. I don't know. We'll have to think of it. Because division and subtraction are like related a little, right? Mess around with that. I want to get you guys, I don't know if I'm going to be able to afford them or not, but I want to get you guys binders. My dad's old one. I've just filled it with graph paper. But as you can see, like, I've got it filled with just me messing around with numbers, thinking of different ways to do it. Also letters. But like, yeah, don't worry about that. It's a little bit too hard. Playing around with stuff. Finding patterns, seeing if things hold up. Like, right here. Here's, went too far. Maybe I didn't. Where is it? Here's what we were working on yesterday. Me planning this out at home, thinking about different ways to do it. I think you guys should have a binder. The reason I didn't want to give you guys something like this or say you needed it is because first day of class, what are you guys doing, right? If I give you a binder, you're doing this. Write that down, write that down! Right? And what's the problem with that? Well, if you're writing it down the whole time, is there any time to think? No. And then you write it down, and then do you go back and look at it ever? Be honest, right? I took the notes. I'm never gonna look at them. Why would you? You didn't understand it the first time. Looking at it now, oh, thanks. Here, oh, I'll keep it. Looking at it now, right? You didn't know it then. Going to look at it now, it's like someone just handed you the notes and you're looking at them for the first time, right? So of course you're not going back and looking at them. I don't know. I don't think note taking is all it's cracked up to be. What is good is trying stuff out and playing around with numbers. Spend some time doing that. I think you guys should have like a journal or something where you're not writing stuff out like, you know, a notebook necessarily, but you're just like, you know, playing around, messing with things, trying stuff out. Maybe we'll get you some of those. Remember, I need to talk about multiplication, division, or subtraction, or sorry, multiplication, addition, or subtraction in your next post. Your choice. Make sure you explain it. Talk about division. So division and multiplication are related, yeah? They're inverse operations, what we call them. They undo the stuff. Can't. Face reveal at 4,000. So I'm grouping it like this, not because I have to, but because it's easier to read. So 6 groups of 4, 10 groups of 4. How many groups of 4 is that going to make? Has to. You don't even need to do the math to check, but we will. Makes sense, right? 6 groups of 4, 10 groups of 4, 16 groups of 4. That's all it is. 4 times 16, according to this, is 64. It is. I can check that pretty easily. Remember that double and half method? Double this, halve that. Yep, thank you. That's definitely 64. I remember that one because my 3rd grade teacher or 5th grade teacher told us 8 times 8 is 64. Pick it up, it's on the floor. Right? This works. Looks like talking about 4s here. So we're still going to be talking about 4s when we're done, right? Groups. We're adding, so we add them together. If it was minus, right? Think about what it would be. 24 minus 40. 6 minus 10, negative 4. 4 times negative 4, negative 16. Yep, minus. Right, that checks out. But what about division? Let's use 100. What's 100 divide? What can we divide 100 by? 25. 25. Okay, let's use the same number, 100. What else can we divide it by? Okay. So according to this, we add, right? That's 100 stays the same, and then we're going to divide by 75. Is that going to be the same or no? What do you think? No. That's not 6, right? What if it's the opposite? What if we have to subtract? Like when it says plus, we minus or something, right? I know, but like maybe it's when it says plus, we minus for some reason, right? We get 2. Well, no, right? But they're related. What about, what if, like, the second number is the same? What else can we divide by 4? Nope. Not without remainder. Yeah. 400. Give me another one. 24? Okay. I just want to keep it small. I don't know. Also been calling on you a lot. I was raising your hand. Smart kids. All 4 of you. It's awesome, isn't it? Adam? Me too. Adam! True or false? Find out. 25. 6. 31. How can we check? Yeah. That's 120 divided by 4 is 30. 4 divided by 4 is 1. Checks out, yep. Another way is to think, well, is 4 times 31 124? Sure, because 4 times 30 is 120. And one more group of 4, right? Yeah. Sure. This works. It looks like the second number is what matters. Now, the reason for this is because in division, we have an amount, right? A total. We call it the dividend. Yeah. You don't have to memorize that. I'll show you why that is. But dividend, how much you make, right? They talk about this when they talk about economics, right? A dividend is what you pay off, or insurance crap, right? Dividend is the amount you have. The divisor is the person who does the dividing, or the people, right? So dividend is like 100, and the divisor is like 4, right? And then the quotient is a word from Latin that means times. How many times? It's asking a question. Can you quote that to me? Can you give me the amount, right? What we're asking. Yeah, sure, why not? I don't care. Count for what? Okay. That's the idea. So the divisor is the number that has to be the same. And that makes sense because the dividend being different is no big deal, right? If I've got 100 and I'm dividing it among 4, couldn't I also have like, oh, by the way, I forgot I have 24 over here as well and I need to divide it amongst you guys, right? I'm going to pay you guys $100. Everybody gets a fourth, right? Oh, wait, sorry. It was supposed to be $124. Give it all back. I got to put it back together. Now I'll divide it up. No. I already gave the 100 divided by 4. Now I'll take the 24 and divide it by 4. Of course that works, right? No big deal. Here's your first paycheck. Here's your second, right? Imagine if that didn't work. First paycheck, I divide it 4 ways. Next paycheck's different. Oh, sorry, guys. I need that first paycheck back. We got to make sure it's fair. Right? Of course. And of course, this doesn't work. Right? It's the same amount both times, but I'm dividing it up differently. I'm dividing it among 25 people, and now I'm dividing that same amount among 50. Y'all aren't going to get the same amount of money. Current musicians, a lot of them are individuals, and it's not so much because of this is why I want to make my music that way, although there is some of that, right? Because you can make a lot of it yourself with computers, right? You don't need a drummer, you don't need all that stuff, you can do it on here, right? But one of the main reasons bands have been getting smaller and smaller and smaller is because there's less money going around. It's hard to get a gig. And if you've got a gig that's paying you $100 and you got 8 musicians, guess what? It's not worth going. Divide that among 8, you're not making much money. But it's just you, he's made $100. So the same amount divided by a different amount, of course, isn't going to be the same thing, right? Can't be. Different amounts divided among the same people? Sure, we're talking apples to apples here. Doesn't matter. We'll do it all at once, right? Because I can think of 100 as 25 plus 25 plus 25 plus 25 divided by 4. I can divide each 4 of those by 4. That's fine. 25 divided by 4 people. Oh, remainder of 1. 25 divided by 4 people. Remainder of 1. 25 divided by 4. Remainder of 1. That's 3 remainders now, right? 25 divided again. Another remainder. Oh, look! Now I'll divide up that 4. See how that works? Totally makes sense. No big deal. These numbers have to be the same. How we're dividing it up must be the same. Now, you know this. You've known it. You've known it. You've known it forever. We're gonna get into a little bit advanced now. Getting ahead. Y'all like fractions? Yeah, no one does, right? Because they never taught you what they are. What's 7 divided by 2? You have no freaking clue, right? Could you guess? 3.5, okay. You like decimals. Oh, that's cute. Decimals suck. You hate fractions? No, you hate decimals. I'm gonna prove it to you. Okay. What's 49 divided by 3? How would you guess? About what? About 13? 13 times 3 is 39, right? 3 more get 42, so that's 14. 3 more get 45, that's 15. 3 more get 48, that's as high as we can go. That's 16. Remainder 1. Something like that. Right? Okay. What if I told you it doesn't have to be that difficult? Is that the bell to go? Yeah. Is this class shorter? Boo! That's not fair. I like you guys. Yeah, I guess so. See you guys later. Mr. Bielema's got to come in and check me out, and not in that way, but check out the class and see what's going on. At least as far as I know. I don't know. Did I show him this one? You guys up to that challenge? You make me look good? Yeah. All right. Appreciate it, boys. Take care. Are you gonna be out for the cookout? Yeah, I'll be out for a little bit. I got to do this crap because all the people that didn't show up, but I'll be out there. But take care. If I don't see you, good weekend. All right.